When you start lesson 3 and you see this chart, I understand that it looks very confusing, but I really want you to think about how this chart is just a way for you to show all the different ways that you can manipulate fractions. Kind of a showcase of your skills, so to speak. You're putting it all on display. For example, let's look at A. A, we worked on how 5 divided by 4 is really a fraction, 5 divided by 4. And last module, when we had an improper fraction, we made it into a division problem and then turned it into a mixed number. We are going to do that for B. So let's go ahead and look at B. And B, we have a division problem of 3 divided by 2, which means the improper fraction is 3 divided by 2. When we turn that into a division problem, how many 2's go into 3? 1. 1 times 2 is 2. 3 minus 2 is 1. So we have this remainder of 1, and that goes over 2. So that becomes our mixed number. We also can look at it here and say 3 halves divided by 2 is actually 6 halves. What? Where did I get 6 halves from? Well, let's look at it. 3 divided by 2 gives you 1, 2, 3, 4, 5, 6 pieces. Let's look at C. C gives us information, we just need to plug it in. For example, it's 4 divided by 6 here. 6 divided by 4. That's 24 fourths divided by 4 gives you 6 fourths. 6 fourths. And when we do the division problem, we have 1 and 2 fourths. I think this box is probably the most confusing, so let's look at this one more time. I have 5 divided by 2, 5 divided by 2, which is 5 halves. When I do the division problem, I have 5 divided by 2. How many 2's go into 5? 2. 2 times 2 is 4. 5 minus 4 is 1. That's a remainder 1, which becomes 1 half. So 2 and a half becomes my mixed number. But this really requires that we draw a picture. 2, 3, 4, 5. Divide each one in half. And 5 divided by 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 10 halves, or 10 halves divided by 2 is 5. That's another way to look at it. Problems, we just need to answer some questions about our thinking. So I'm going to jump down here to 3 and say a caterer has prepared 16 trays of hot food for an event. First thing I'm going to do is draw those 16 trays. I know, it feels like a lot, but I think in the long run it may help us out. So we're going to draw those 16 trays. Then we'll read, the trays are placed in warming boxes for delivery. Each box can hold 5 trays of food. How many warming boxes are necessary for delivery if the caterer wants to use as few boxes as possible? So our fraction here is 16 divided by 5. That's our fraction. And if we convert that, how many 5's go into 16? 3, 1 left over. I think they're going to need 4 warming trays because 3 of them will be full and the last warming tray will only have one, warming box will only have one tray in it. But we're going to prove that over here with our picture. So 5 trays go in each box. Here's one box. 1, 2, 3, 4, 5, 2 boxes. 1, 2, 3, 4, 5, 3 boxes. And I still have this tray over here that is not in a warming box, but it's going to have to be warmed. So there'll be 4 warming boxes because 3 of them will be full and 1 of them will actually only hold 1 tray. And then this next question says, if the caterer fills a box completely before filling the next box, what fraction of the last box will be empty? Well, 1/5 of the last box will have something in it. Right here we found that there's 1/5 left over, which means this one will be full, which means 4/5 will be empty.